Alright, we're going to work the next molecular shape problems, E and F. So we'll start with E. Bromine has 7 valence electrons, so does fluorine, but I have 5 of them. So basically a 6 times 7, which is 42. Okay, so we have 42 electrons. Our central atom is the first one listed, which is bromine. So we've got fluorine, 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 fluorine. Wait, I gotta get a 5th one in there. There's the 5th fluorine. So then I'll go fill the externals. I started with 10 electrons and now I'm adding in, and I'm going to fill these up. So that's 5 times 8, which is 40. So at this point in time where I have filled up all the externals, I still have 2 left over, so I'm going to put them right over here in between the 2. So I have 6 electron regions, 5 single bonds and 1 lone pair. So if I have 6 electron regions, then the shape octahedral of electronic shape is octahedral. So that's what a 6-sided is. But our molecular shape, and if we look at it, it's basically a square with 1 up and 1 down. It doesn't matter where you place the lone pair, but if you put it here, it's easier to see. The shape of it is a pyramid, but it's got a square bottom, so it's square pyramidal is the molecular shape. The bond angles are all 90 degrees. Yes, there's the lone pair, but 90 degrees is already tight and you really can't move it, so 90-degree angles stay as 90-degree angles. Now that's not true for 120s and 109s. They will bend a little bit, but 90s cannot. So then we have the polarity. Well, is this going to be a polar or non-polar molecule? It's going to end up being a polar molecule because we have polar bonds. And remember, since you can't see this, you're just getting a square pyramid, which I drew one badly there. It's unsymmetrical. So unsymmetrical with polar bonds gives you a polar molecule. And then hybridization. Again, we have 6 regions. So therefore, we're going to take 1 S. That's all we got. 3 P's. That's all we got. We can't add more of those. So that gives us a total of 4. Remember, we're adding the exponents. 5, 6. So 1 S, 3 P's, and 2 D's is a total of 6 regions. Hybridization is easy if you remember to add exponents. So there's that one. Now on this one, this is an ion, sometimes hard to see, so I've got it written here. So we have 7 plus 7 times 2. And because it's a plus, that means we've lost 1. So 7 times 3 is 21, minus 1 is 20 electrons. Our central atom will be the chlorine because it's listed first. So we've got fluorine and we've got fluorine. So 2, 4, 6, 8, 10, 12, 14, 16 electrons with 4 more left over, so 18, 20. Fluorine's happy, chlorine's happy, and fluorine's happy, so we don't have to add any more or move any multiple bonds. However, because this is an ion, we have to bracket it and put the positive there. Now, if we look at chlorine, which is our central atom, we have 4 electron regions. So our electronic structure is tetrahedral. But if we look at it, two of the regions are lone pairs. So technically you don't see that. All you see is this. This is what you visualize. So that means that the molecule shape is bent. Remember, lone pairs have an effect on shape, but you can't see them. They're like glass. So we have our bent molecule. Our bond angles, because of that, again, normally we would start with 109.5 because our angles are based upon the electronic shape, which is tetrahedral. However, these are going to push each other, so they're going to push down. So this is less than 109.5 because all of these are going to be greater than 109.5. So those are our bond angles. Our polarity, if you looked at it, it would be bent, so it's totally unsymmetrical. It has polar bonds, so if it was a molecule, then it would be polar, but it's not. It's an ion. And ions are not polar. They're ions. Alright, hybridization is, we're back to 4 regions. That means we need 1 S and 3 P's. So in ClF2+, the hybridization is sp3.